Hello mate, and welcome to another exciting episode of Let's Code Season 5. So in this episode we're going to start building our second minigame because we've already got our awesome coin toss game up and ready to go. So the first thing we need to do is we want to create a new file inside our minigames folder. So we're just going to do that now. Right click there, new file. And I'm going to call this one snake.rpy. Hit enter, and then we have our nice empty file ready to go. So we're going to go to our template and we're going to find out where we've got our init Python. So as you can see here, we've got init Python 1. So we're going to put init 2 Python up here. So that we are going to initialize this chunk of code immediately after we've initialized this chunk of code, so that it all does it in one go. So what I want to do is, you'll notice at the start of our coin toss game we import random and we import math modules. So if I were being 100% efficient with my code, I wouldn't bother importing any of those modules again, purely because we don't need to, because we already have. However, because I want my code to be completely modular, i.e. I want to be able to lift this code out of this game and plonk it straight into another game if I so choose, then I'm going to import the modules that I need for this piece of code as well. So what I am going to do is I'm going to import random again, and I'm also going to import a module called Pygame. Now I know some of you may have already heard of Pygame, but Pygame is basically a module that enables a lot of game playing functionality to Python. So we're going to use that for what we're about to achieve. So what we're actually going to build here is the classic snake game with a little bit of a twist, but the important thing is how we're going to achieve it. So previously we'd used screen code to achieve what we wanted to achieve, and that is not necessarily a bad thing. However, if we're having some things animated on the screen, it's not necessarily the most efficient way of doing it, because Ren'Py does a whole bunch of stuff in the background, and we want to kind of minimize that as much as possible. So what we're going to use is something called User Defined Displayables. And what you need to think of a User Defined Displayable is it's kind of like a picture frame, in that you can create this picture frame and inside it you can have anything you want, whether that be just a still image, an animation, or even a fully functioning game inside that picture frame, and then Ren'Py will treat it just as if it's an image, and you can put it anywhere on the screen that you like and it will work basically. So because the snake game is generally quite a small thing, if we had a snake game that took up our entire screen, then the player would get incredibly fed up if the snake started off in the top left hand corner and had to go all the way down to the bottom right to pick up the food. So we're actually only going to use a very small portion of the screen for this, and then we can put it on the screen as a displayable, and then we can have whatever we want in the background instead. So what we need to do is define our displayable. So what we need to do is call a class. So we're going to say class, and then we're going to say snake game, and it's going to derive from renpy.displayable, like so. And then we're going to say our define. If you remember from classes, we have to define our initialization. And all I'm going to do now is I'm going to say self, and then it's going to take a whole bunch of KWArgs, keyword arguments, like so. And then we can just plop that there, like so. Next thing we're going to do is we're going to say super snake underscore game. So we're going to call our class, but we're going to override our initialization. Like so, and then we're just going to feed in those those keyword arguments, like that. And what I'm going to do now is I'm going to call a method that we haven't written yet called reset, and you'll see why. Like that. Okay, so during our initialization, all we do is we call a method called reset, and our reset method is going to basically set up all of our starting variables. So I'm going to pop that here, and then I'm going to stick any code that we want on top of it afterwards. But define the reset method, and we're going to make sure that it's referring to itself. the instance of the class. And then we're going to say global, and we're going to have a variable to store our score in. So we'll go for snake score like that. Okay. So even though that variable doesn't actually exist right now, we are going to define it in this method. Now we can set up our properties. So the first thing the snake needs is a body. So we're going to say self.snakeBody equals, and then we're going to give it some properties. Now the middle of my screen is 960 by 540 in a 1080p screen. I know I'm using a 4K screen, but that's neither here nor there right now. But we're going to give it 3 segments. So I've actually gone the wrong way here with my curly braces, foolishly. Meant to be that way around. Minor oversight, but these are the kind of things that can catch you out if you're not paying attention. So the next one is going to be 10 less to the left, because I want my block size of my body segments to be 10. So this one is going to be 950 by 540. And then the last segment, because it's going to have 3 segments, is going to be 940 by 540. Like that. So I can now say that I want my block size to be 10. So like that. I also want to set the direction of the snake. So I'm going to say self.snake direction equals, and this needs to be a tuple, because bear in mind we're working in 2 dimensions. So we're going to have a, in this case, because we're moving from left to right, so our X direction needs to be our block size. Everything's going to be block size 10 or whatever we set this up to be. So if we want things to be bigger on the screen, we can just change this property, because we're always going to make sure that everything is done relative to the block size. And then it's not moving up or down, so our Y direction is going to be 0. Now we can set up a speed. If we can remember how to type the word self. And I'm going to say snake speed here, because I might use speed in another. In fact, it doesn't matter because it's a class property, so we'll just call it speed. And I'm going to set that to 0.05 at the moment, because bearing in mind that computers work very, very quickly these days, if you set it up to be speed of 1, your snake is going to zoom across the screen faster than you can see it. So we want to be able to see these things. Next thing I'm going to say is self.score. This is not the same as snake score. So snake score is the global variable that we're going to access from outside of our user-defined displayable. Sorry, getting my muddles worded up there. But the score itself is going to be kind of like the internal number that we refer to whilst the player is playing, so that we don't have to keep accessing this variable and updating it. We only need to update this when the player either wins or dies. So score is obviously going to be 0 because we haven't started playing yet. Now we get to set the area size of the screen. So I'm going to say self.area size is going to be 800 for now. And then render size. This is us basically telling Ren'Py the size of our screen. 1920, 1080, and again these properties will become valuable to us a bit further down the line, but don't worry too much right now about why I'm adding so many things, because essentially accessing things from outside of our UDD takes more time than it does to just tell them what they are in here. If you wanted to have a value that just checked on the Ren'Py settings or the preferences and put that value in there, then you are more than welcome to do so. Okay, so now we want to do the food position. Now remember, we are not creating the class for the snake. We're creating the class for the entire snake game. So all of our important properties need to come in here. So self.food position, and we're going to give it an X and Y position. Now we need to use our random model, but we need to do some extra stuff as well. So we're going to say random.randint. And I'm going to say the position is going to be between 1 and 80. And then I'm going to multiply it by 10 so that it's somewhere in our screen. So the reason I'm doing this is that our snake is using a segment size of 10. Okay. And our screen size is 80. I don't want my food to be at positions 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. I either want it to be at 1 or 10 or 20 or 30 or 40 and so on my screen of 800. So that's basically what I'm doing here, is by saying 1 to 80 and then timesing it by 10, I know that my food X position is always going to be on a multiple of 10. Okay, so now we're going to say self render underscore 0. That's, so we're going to say it's going to be, we're going to add on the dimensions of the screen divided by 2 so that it appears in the middle of the screen relative to our position X divided by 2 minus self dot area size over 2. So what I'm trying to do at this point is I'm trying to make sure that my play area, the little box that we're going to be playing in, appears in the middle of my screen, and that the food position is going to appear somewhere within that box. So it's a little bit of faffery going on, but this is just me trying to make sure that everything appears in I don't want my box to be in the top left hand corner of the screen, because that's just going to look crap. Okay, self dot food position Y, and we can actually just copy and paste this and change a couple of the variables. So we're going to Control C, Control V, change that to Y. Our screen is 800 by 800, or rather our play area is 800 by 800, so we can leave this the same. We have to change this so that it's accessing the second portion of our render size variable. That's all we need to change for that one. So we now need to give our score a position as well, because we want our score to appear in a position that's actually useful to the player. I'm going to say self.score x, and then again I'm going to say self.render size 0, because that's the x coordinate divided by 2, so that it appears in the middle of our screen again. And then now that we've got a global snake score, I can actually set our snake score variable. Yeah. And we can set it to 0, because when we reset the game, we want it to be 0. So now, all we've done is we've taken this place where we set the properties up in here, and we've put them in a method so that we can recall them if we want to reset the game for any other reason other than initializing. So for example, if the player crashes into itself, then we can just hit reset straight away, and they can start again, rather than messing around. Okay, so now we have to go in and build the methods that a UDD actually needs in order to be able to work. And those first ones, the first one of those is render. So we're going to define render. And we're going to take in some properties. We're going to take in self. We're going to take in width, if I can spell, height, ST and AT. Okay, so don't worry too much about what ST and AT are. They are just references to how much time has passed since this was redrawn. So if we were using those variables for anything in particular, then we would have access to them. But right now we're just fulfilling the requirement. We're ticking the box of having those properties put into our render method. So now we have to actually define the render itself. So we're going to say render equals renpy dot render with a capital R and self dot render size 0, and then I can just copy that and put that in there. Okay, so all we're doing, think about this is, those of you that are familiar with Pygame, this is us declaring our surface size. So this is like us basically saying to Ren'Py, this is the size of our canvas that we're going to work on. And in this case, it's going to be 1920 by 1080. It doesn't have to be that big, to be quite honest. We could just say 800 by 800 if we wanted to. However, I'm giving you guys the freedom of just playing with those numbers as much as you want to. Next thing we have to do is actually tell Ren'Py that there is a canvas. So we're going to say render_canvas, if I can spell canvas, equals render.canvas, like that. And now that's our canvas initialized. Now I need to set up some rectangles so that Ren'Py knows where to draw things. So the first thing I'm going to do is define the rectangle for the playable area and then the total area. So I'm actually going to have the playable area is going to be 800 by 800, but I'm actually going to have it bordered by an area that's slightly bigger so that we can have a little border around our play area so that the player can actually physically see where the play zone terminates. So the first one is going to be just the standard area. So we're going to say area rect, which is just shorthand for area rectangle, equals pygame.rect. And then we're going to need to give ourselves, I think, 3 lots of brackets. So render.get_size 0 divided by 2 minus self.area_size divided by 2 minus 20. So my X position is going to be that, basically. So it's going to be the center of the screen minus 20, because I'm going to make it 40 bigger, so that we're going to have a border of 20 pixels around the outside of our entire area, basically. So next one is going to be essentially the same, but instead we're going to call the property for the y-axis. So I'm actually just going to grab all of that. But I need to grab that much of it. And this is going to be 1. I'm actually going to give myself a little bit more space at the top to put the score in. So I'm actually going to call this minus 80. This is going to appear quite a bit above the play area as a whole. Yep, so happy with that. Hopefully you're following me. Don't panic too much. Again, the whole point of this render get size divided by 2 minus self area divided by 2 is purely just finding the middle of the screen and then moving half of the total play area size back. That's all we're doing there. And in this case, I'm then moving another 20 pixels to the left and another 80 pixels up, so that we definitely have a bit of chunk of space at the top there. So now we can just double check that we're actually terminating all of our brackets correctly, which we are. So now we can put a comma there like that. Now all I have to do is say self.area size plus 40 and self.area size plus 100, because I only want it to be 20 more at the bottom, but I want it to be 80 more at the top. There we go. So that's our play area, or sorry, our main area rectangle. Now our play area is a little bit simpler than that, but we can reutilize some of the code. In fact, we can reutilize most of the code, to be honest. So playable area equals, and then we can just copy this chunk of code here. Yes, I'll respell playable correctly in a moment. Playable area. And now all we're going to do is remove these minus 20s from there, the minus 80 from there, and the minus 40 from there, and the minus 100 from there. So now we have 2 rectangles. One is bigger than the other, and that's going to be the back rectangle, and this is going to be the front rectangle. And this playable area is the area that our snake is going to be able to move around in. So now we can actually put those rectangles on the screen. So render_canvas dot rect. So we're now telling the playable area canvas, or rather the render canvas, that we want to draw a rectangle on it. So we first have to give it a color. So I'm going to go with 50 by 50 by 200. Those are my RGB, and then my alpha color goes there like that. And then I'm going to tell it which rectangle to draw, and we're going to say area underscore rect. Now we're going to draw a playable canvas. So we're just going to copy that, paste that again. Now we're going to change the colors slightly. I want this to be slightly darker, so we're going to say 25, 25, 100. Still going to have an alpha of 255, and then we're going to change this to playable underscore area, and that will be that displayable, or that's displaying on the screen. Now I also want to draw another rectangle for my food. So render dot canvas, underscore canvas dot rect. This one is just going to have the color, which is going to be bright red, 255 by 0 by 0, and then we need to add another bracket on there, and it's going to be our X position, Y position, and our size. So we're going to actually define our rectangle for our food square within the canvas rect code rather than having to do it separately. These bits is just a bit too much code. Imagine putting this inside these brackets would just be too much to read, so I'm trying to keep readability as much of a priority as possible so that when we come back, if there are any bugs, we can find them fairly easily. Okay, so self.food, and we can just copy this, Control C, Control V, self.food position Y, comma, and then we just want self.block size twice because it's going to be a square, so it's self there. Copy that so we don't make any typos. If we press the right button, Control V, there we go. So that is the rectangle for our food. It's going to be block size squared at food position X, food position Y. So that is the playable area, and our food are now being drawn on the screen. So now we can start working on the code for the snake itself and the score text. So let's do the score text first, actually. So we're going to say score underscore text equals text. We need to tell Ren'Py that this is a text element. And we're going to give it just a really simple score like that. Put some curly braces in there and use the dot format method. For those of you who don't know what the dot format method is, if I'm creating a string, what I can do is, if I want some of the text within that string to be conditional, i.e. based on a variable. Now in Ren'Py you can use square brackets and put the variable name in there, but that doesn't always work how you want it to. It's much easier to use the dot format method where you put in a set of curly braces where you want the text that you want to be replaced with the value of your variable instead, and then we can just declare what those variables are going to be in a set of curly brackets at the end. So in this case, we want self.score to sit in there, and we want a size equals, and I'm going to say 30 for now, like that. And we can add styles and stuff in a bit as well if we wanted to. So let's just jump to the next line, score underscore render. So we can't just plonk this text on the screen like we do in normal Ren'Py. This is sort of semi-Python Pygame code, so we need to do it properly. So we now need to create a render of this text. So we're going to say Ren'Py dot render with a small r, score underscore text, width, height, st, 80, like that. And now we can say to our render screen to blit, or put on the screen, score underscore render, and then where we want it to appear. So we're going to say self dot score x. Remember that variable that we created ages ago, which is basically just halfway across the screen for now, but we may end up changing that. And then 75 on the y-axis for now, and then as I say, we can just sort of move it around as we need to. So now our score is going to appear on the screen. Let's just save our file so that we don't lose any of our work should something go horribly wrong. Now we want to draw our snake. So we're going to say for segment in self.snake body. Now we need to draw on all of our snake body segments a square. So we're going to say render underscore canvas dot rect. And I think we're going to make it, let's just go for a wacky color, 255,255. I think that's yellow, I want to say. So that is our color. Now we're going to say our X, Y, and size like we did before with our food. So we need to do segment 0 because we're cycling through and we're saying that for each instance of whatever it is we're cycling through, we're going to refer to it as segment. So we're looking for the first property in our tuple, followed by the second property in our tuple. Then we're going to just call block size again. So I can just go like this, copy that, press C, stick that in there, jobs are good. Like so. Now we need to move our snake in the direction that it's going to go in. So we're going to say new head, as in the snake's new head, is going to be a tuple. And I'm going to say map lambda I, j. So yeah, I'm going to use I and j, just making sure we didn't accidentally use those properties elsewhere. I plus j self dot snake body 0 self dot snake direction. Make sure that I've got those variables spelled correctly. We'll just double click on that one, paste it there to make sure. Snake body, just double click on that one to make sure that that is there correctly. So we're just using a lambda function called map to essentially create a new property at the position of snake body plus self direction, basically. Nothing too complicated happening there. It's just we're using the most efficient way, the least amount of code possible, essentially. Okay, so we've got that, and now what I need to do is insert that into the position 0 of my snake. So snake body dot insert into position 0 new head. Because if we just appended this to the end of our snake body list, it would be in position 3 rather than in position 0, and we don't want that. We want the new position, or the new head, to always be at position 0, because position 0 is where we're going to do our collision detections and stuff to see if the snakes hit the food or the barrier or itself. Okay, so now we can create a couple of rectangles to check for collisions. So food rect is going to be pygame.rect like that. And actually we can copy the code that we borrowed up here for the food, and we can put that into this, in this bit here. So we'll just go for double brackets and plonk that in there like so. And then we just need to add a couple of brackets in there like that. Now, since I'm doing this, excuse me, since I'm doing this, what we're going to do instead is we're going to move this code and we're going to pop it up here where we define the other rectangles. And we're going to change the name so that it actually says food rect so that I know what the hell the variable is. And then we're just going to copy that, paste it in there, and then remember to terminate our brackets. It's a good idea I went up there. So now that we've done that, we've got, again, we've minimized the amount of code and we've created the rectangle that we needed to use for collision detection, and we've just used it for the drawing method as well, which has made life a bit easier. So what I'm now need to do is, now I can't define the snake's head collision rectangle down here because we've moved the snake's head. And what we want to do is we actually want to check for collisions before we draw the snake. So we need to do it after the draw method, so that by the time it cycles round again to draw, it already knows whether it's collided or not. So we need to do a rectangle for the head. Head rectangle equals pygame.rect. And self.snakebody is all we need for the X position. Like that. And self.block size and block size again, so we can just borrow this bit of code from up here. Open some brackets, get rid of that nonsense. Make sure we've terminated all of our brackets. So that's that set of brackets, and that's the outer set of brackets. Perfect. So that's that. So now we've got our rectangle around, and this is imaginary, an invisible rectangle, like a force field around the outside of our snake's head that we're going to use to detect collisions. So let's before we do anything else, let's check for collisions with the food, because that's essentially what we're after. So if head rect dot collide rect food rect. So if the head rectangle, this one, collides with this one, in other words, if we pick up our food, then what do we do? First thing we need to do is redeclare our positions for our food. We need to move it to somewhere else, so we can just copy this bit of code and pop that in there, like that. What I'm also going to do is increase the speed of our snake, so it's going to speed up every time you pick up food, so we'll just pop that in there as well, and then we'll say plus equals, but I don't want it to be loads, so I'm going to say 0.001, and then we also need to do self.score, and I'm going to give you 10 points every time you eat food. We also need to make sure that we clamp our speed, because we don't want it to just get infinitely faster, otherwise within sort of 4 or 5 pieces of food eating it's going to become unmanageable, and then if we go, you know, too mad, it's going to be basically unachievable. So if self.speed is less than or equal to 0.001, it's meant to be a minus there, sorry, my bad. We're using the speed as the delay basically. So if it's less than 0.001 equals 0.001. So whilst we're referring to it as speed, it's actually the delay that we are applying to our game. So we're just reversing it back. Basically, the lower the number, the faster the snake goes. Else. So if it hasn't collided with food, then we're going to remove the tail. Because if you remember, in this section up here where we created a new head, what we've done is we've drawn our 3 segments of our snake, then we've created a new segment directly in front of the snake's head, and then we've added that to the snake list, which means each time we do that, the snake becomes 1 longer. Now, the only time we want it to keep that length is when we've actually eaten some food. So at this point, we're checking, have you eaten food? If the answer is yes, then great, we'll just increase your speed a little bit, give you 10 points and do nothing else. If you haven't eaten some food, we're now going to remove the last element from the snake body list. So what we're going to do, self.snakebody.pop. Remove the last item from our list. Nice and easy, yeah? Okay, so now we're going to do a check on the barrier. So we're going to say, if not head rect.collide playable underscore area. So in other words, if we haven't collided, if we're currently not within the playable area, I suppose is a better way of saying this, If we're not within the playable area, then we're just going to do a self.reset for now. So if you crash into the barrier, your snake will be reset to 3 segments, your points will be wiped, and we'll start again. So don't hit the barrier is the point I would be making there. Okay, so what else have we got to do? We need to check whether we bang into ourselves, but for now I'm going to leave that just for a moment, and I'm going to say renpy.redraw self, and then I'm going to put a delay in of self.speed. My god, I'm having major finger trouble today. Self.speed, and then return render. Okay, so there's probably a bunch of typos in there, but that is essentially what it's supposed to do. So the only thing now we need to do is create another method called the event method that checks for key presses, because we actually need to be able to, you know, move our snake. So define event, self event, shorthand for that is EV, X, Y, ST. Again, these are things that we have to declare, ticking boxes and whatnot, so don't stress too much about what they mean for now. We might cover that in a later episode, but for now let's just get the code done. So if ev.type equals pygame.key down, so if we've pressed a key, then we're going to check to see if ev.key equals pygame.key underscore up. So if we're pressing the up key, now we need to check that we're not already moving up or down, or rather we're checking to make sure that we're not moving down. If we're moving up, it doesn't matter, but we can't go back on ourselves, so we need to make sure that we're only turning either left or right relative to the direction we're moving. So we're going to say if self.snake direction is not equal to up, which is 0,10, I think. We'll find out when I try it. Self.snake direction equals 0,-10. Okay, yeah, so we're checking if we're not moving downwards, straight down, and we press the up arrow, it's going to go in that direction. If we are going down and we press in the up direction, it won't do anything. So now we can copy these bits there, and we can now say if we're going down, we press the down arrow, we can just swap these like so. So if we're pressing left, if we are not moving right, so we need to change these so that that's actually 10 and 0. Then we're going to say that's -10 and that's 0. And if we are press right, if we're not moving left, so we need to be saying -10 there, 0 there, then we will go 10 there, 0 there. Awesome. Right, I think that should be pretty much everything we need to do to start off with. So in order to actually display this on the screen, we need to do a couple of things. So we need to define our snake displayable as a variable. In other words, we need to declare it, and then we need to actually call it within a screen. So in the bottom of this file, we can just add a default bg, we'll call it snake_game. In fact, we can do that within the screen code, to be honest. Let's do that. Let's make it life a little bit easier for us. So we're going to say screen, we'll just call it test screen for now. And then I'm going to say snake equals snake_game, making sure that we're using our class name. Yep, snake game, like that. So we're saying now this displayable that we've created here is this displayable. Add snake, and then I'm going to give it some position properties. I'm going to say anchor needs to be 0.5, 0.5, and a line also needs to be 0.5, 0.5. So I'm basically telling it that the anchor for this displayable is going to be in the middle of it, and we want that anchor to sit smack bang in the middle of our screen. So all I need to do now is call a Ren'Py label that actually displays that screen and then pauses until we do something else. So we can say label snake game like that, and then show screen test screen pause return. Okay, so all I need to do now is call that from probably, let's say, our main menu. Let's just go straight to that. So if we remember, if we come back to our navigation menu where we call our coin toss start, we can actually add another one. And we can just remove that bit and call it snake. And then we're going to call the label, come back to our snake label, and we just copy that so we don't make any typos. Okay, so we'll double check our code to make sure we're good to go, and then we'll give it a test. So let's have a look. Oh, there's immediately a piece of code wrong there. I forgot to put an equals symbol in there. So let's keep looking just to make sure we've got any, we've caught any mistakes. Oh, there's another one. That's meant to be there. That's our XY position. That would have thrown up an error because that would have seen, well, it sees whatever's in the brackets as the position, and because I had the brackets only on score X, that would have just seen it as an integer, not a tuple. And I can't see any other mistakes, so I'm not saying I've done it perfectly. When we try and test it, it may very well still not work, but let's give it a go. Alright, so it got as far as loading without falling over, so now we click on our snake and let's see what happens. Oh, so yep, that bit's working. Use my arrows to control it. Excellent. So far so good. We're getting longer each time. We are looking good. We are getting slightly faster each time as well. The food is moving randomly, and our score, that's a bit of a problem. One that we might investigate later is that it is actually possible to go back on yourself if you press the buttons really quickly. But it's looking pretty good, I would say, if I do say so myself. And this displayable, as I said, is treated by Ren'Py as an image. So if I wanted to fade it in, if I wanted to apply other transforms to it, I can do that. The code all runs within the displayable itself. This is where I show how terrible at this game I actually am. Awesome. Happy days. And then we can click to just exit the game. So we might change how it's actually implemented in terms of, at the moment we just have pause. So we might put a while loop in there and put some kind of check variable within our code that says if that variable is true, then we'll stay within the while loop. But for now, this kind of works fine. So the last thing I want to do is put a bit of a check within our code to see if we have collided with ourself. So if the snake bumps into any part of its own tail. So what we need to do is, again, cycle through our segments. And this time we're going to use enumerate. Within enumerate self.snakeBody, because we want to actually access the indices or the number within our list that each value is. So we're going to say if segment 0, as in if the index is greater than 1, because we don't want it to bump into this, we don't want the head to bang into itself, and we also don't want it to detect whether it's colliding with the segment directly behind it, because they're always touching, so there is always going to be a collision there. we want to check with the third element in our list. So we're going to say temp_rect. We're going to declare a temporary rectangle equals pygame.rect segment 1, and then self.block size and self.block size. Like that. So we're creating a 10 by 10 rectangle around each segment in our segment that isn't segment 0 or 1. And then we're just going to check to see if it collides with our head. If head rect dot collide rect with temp rect. If it collides with itself, then we'll just say self.reset, same as we did previously when we collided with the size of the playable area. So that should now work. So we'll run another test and let's see if it does what it's meant to do when we collide with the side. Yeah, it resets when we collide with the side, so we know that our reset method is functioning correctly. So we can just do a very quick and try and get a score up so that I can actually it's going to be tricky when that happens because I'm terrible at this game, but you know, part of playtesting is obviously playing your own game and hoping. Now that's a problem. Yep, that's appeared outside of our playable area, so there is a problem there that we need to resolve. So let's go back to our code. And we can look and see that when we create our food position in the Y direction, it does go from 1 to 80. But remember that our playable area is only 800 long or 800 wide. So we actually need to set this to be 79 so that our food will always spawn between position 10 and position 79. In fact, it could actually spawn at position 0 if we wanted it to. So let's just change that like that. And then we need to copy and paste this code back into the actual reset method, like so. So that our food is always going to spawn within the playable area and not outside of it. Otherwise, we get into that situation where we're trying to play test and we need our snake to get to length that we can actually do that, and it won't allow us to do it. So let's try that again. So let's give it a go. Keep on trucking. As I said, I'm terrible at this game, especially when the speed gets up. And we just need to be able to get it up to a sufficient length that, oh god, we can actually test whether we collide with ourselves. So once I get up to about 100, my reflexes should be quick enough that I can actually try and crash into myself and check to see if it works. Okay. Hey, there we go. So we crashed into ourselves and the game reset. So we know that that works. So basically, that's pretty much it, to be quite honest. You can try downloading fonts that will enable you to make the score text look more like the rest of the game, you know, all digitized and all of that. And you can set that up as a style. In fact, I'll do that. So I'm just going to go and find a font to use and then I will come right back. Okay, so I found a font that I want to use. So all I need to do now is I'm going to do it at the top here just so that I can see it. I'm going to set up a style and it's going to just be called snake score underscore text. And I'm going to call the font GUI fonts 8-bit UD.ttf. Color going to be hash FFF, and Y align is going to be 0.5. Cool. So and I can save that, and then all I need to do is actually apply that to where I draw my snake score text just here. I can now say style equals, and then grab this, stick that within there. Remember to put a comma after it so that Ren'Py recognizes that that's a keyword argument as well as that, not that they're both attempting to be the same. And then we can do another play test to see if it looks good. So let's see how it looks now. Oh, there you go. Yeah, much better. Now it actually looks pixelated just like the game is. And there you go. When we get some points in the bag, looks pretty good. I'm pretty happy with that. And there you have it, folks. That is a fully functioning snake game created using a user-defined displayable that you can embed pretty much anywhere, not only inside this sort of setup of game, but you can basically, once you've created this UDD, you can put it inside one of your standard Ren'Py games as just an image that you want to show on the screen. So if you want the player to be able to get to a certain score within this mini game to progress to the next stage of the story or whatever, you can put conditional statements in or whatever. Basically, that's the beauty of user-defined displayables. Now, before you get carried away and excited, I do need to point out some things. Ren'Py is not, or Python more importantly, is not a platform that works particularly well for things like 3D games. Okay, there are modules that will enable you to import OpenGL within Python and use its functionality, but if you think you're going to be able to make the next Doom or the next Quake within Ren'Py and stick it on the screen as a user-defined displayable, you're going to be very disappointed, because it's just not fast enough to be able to do that. It's going to look very blocky, very jerky, and there are better engines out there for that type of content. Remember that Ren'Py is a visual novel engine, and Python is not really a game-driven programming language. So don't anticipate that you're going to be able to go out there and create too amazing of a mini game. I mean, this in itself is already quite a cool little mini game to be able to have inside your game, because it is, as you can see, running quite quickly. But that is because all we're doing is drawing rectangles on the screen and checking to see if they collide with each other. That's essentially all we're doing. So yeah, Ren'Py can cope with this. Python can cope with this quite nicely. But yeah, I know I suck at this game. But yeah, don't expect to be going out there and making, you know, the next amazing 3D game within the Ren'Py engine. For that, you're going to have to move into C# and Unity, or C++ and Unreal Engine, which are things that we're going to be covering in future videos, not in this series, but on this channel. But anyway, hopefully you found that cool, guys. Thanks ever so much for watching. I look forward to seeing you in the next one. But until then, you take damn good care of yourselves, all right? Bye-bye.